Hello friends, welcome back to my channel. In this video we want to be talking about mathematical method, and the topic we are going to be looking is curve fitting. Yes, curve fitting. Now before we look at this topic, my name is Mas Atoka, also known as Kingsmatics. I have a full video on any topic at all you want in math, physics and calculation in chemistry. So if there's any course, any topic in these three courses I just mentioned that you find very difficult, just drop the name of the topic in any comment section of any of our video. Okay, in the comment section of any of your video, and then we are going to be sending you a link that will help you to understand it from the basic to the advanced level. Or you can just go straight to our playlist, and then you will find where I rationed or put each of those topics in a playlist, so you find the particular topic you are looking for and watch that. Okay, so now let us continue. Now the idea behind this curve fitting is very simple. It's just to represent a given set of data in a polynomial. Okay, you just want to fit in a particular set of data into a given polynomial. For example, now we want to fit an example. We want to fit in xi comma yi, where we know that our I will start from 0, 1, 1, 2, 3 and so on. So we want to fit in this particular data here, okay, into a polynomial, say y is equal to a0 plus a1x plus a2x squared plus dot dot dot. It continues that way. Now the polynomial could be of degree 1, degree 2. I hope you know that if it's polynomial of degree 1, then we are stopping here. Yes, if it's degree 1. But if it's polynomial of degree 2, you are stopping with s squared, degree 3 s cubed, like that. So but in this particular video we are going to be dealing with polynomial of degree 1 and degree 2. Okay, just the two of them. So now there are so many methods of fitting this into this, and the first method, and the one we're going to be looking at, is called the least square method, the least square approximation method. Okay, the least square approximation method, the least square approximation method. Now for this least square approximation method, since we are given data, okay, so we just need to look into the least square approximation method. We are going to be starting with the first degree, polynomial of degree 1. Like I told you, we are going to be looking at polynomial of degree 1 and degree 2. So for polynomial of degree 1, permit me to scroll up. Okay, for polynomial of degree 1, which means we are going to have that y is equal to what? a0 plus what? a1x. This is polynomial of degree 1. So we want to get a value, we want to get the value of this a1 and a0, and then come back and put it in this equation. We are done. So once you can get the value of a1 and a0 that can minimize or fit in this into this, then you are done. Okay, very simple. So if you can get the value of a1 and a2 that can minimize this thing and make it fit into this equation, then you are done. So the basic thing is what? To get the value of a1 and a0, then come back and put it here. We are done. Okay, so how do we do that? We do that by getting a particular residue. So the first thing to do is to get your residue. Now our residue S is given as the summation of I starting from 0 to n of your yi minus your yi. Okay, you see that the first one is a small letter, all squared. Please don't forget this square. Students normally forget this square. This is the formula for residue. Okay, it's very easy. The summation of I starting from 0 to n of yi minus yi. So now this your yi here, this small letter yi here, is your polynomial. Okay, why the capital letter yi here is given as the capital letter yi is equal to what? a0 plus what? From this your polynomial you can get it. Your yi will now be what? a0 plus, what do we have here? a1xi. Okay, that is for degree 1. But if it is degree 2, I'm going to have that the capital letter yi will now be equal to what? a naught plus what, a1 xi plus what, a2 x squared I, like that. Okay, so now having known this, let us now do our magic by substitution. So we are going to carry everything here and put inside this place. Then we'll get our a and a naught and a1. We are done. So therefore we have that our residue s will now be equal to what, the summation of I starting from 0 to n of your yi is here minus your capital letter yi is giving us a naught plus a1 xi. Okay, so don't forget all squared. So if I open this bracket with minus, I'm going to have that my s will now be the summation of I starting from 0 to n of yi minus a naught minus a1 xi, not s1, si, all square. I hope you know where the I is coming from because of the I here. Okay, so now according to your calculus, if you can remember your calculus, you remember that the first derivative according to calculus, if you want to minimize the residue at minimum residue, at, because our aim is to minimize it, so at minimum residue, we are going to have that the partial s over, since we are looking for our a and a naught and a1, so it's going to be partial s over what, partial a naught will now be equal to what, 0. Please take note of that. And the partial s over what, partial a1 will be equal to 0. So that is how to minimize your residue. So let us do that and then we are good to go. So to do that now, we are having that our partial s over partial a naught will now be, to differentiate this everything here with respect to a naught. And I hope you know how to differentiate something that has power. You have to differentiate the inside and use it and multiply the differentiation of everything. So it means differentiate the bracket, differentiate everything. I have a full video on differentiation. You can watch that. For example, if I have 2x minus 5 all raised power 3. So how do you do that? And you're differentiating with respect to x. You differentiate inside here. Differentiation of 2x is 2. Differentiation of minus 5 is gone. Okay, we have differentiated inside. You're going to use it and multiply the differentiation of everything. So we're going to multiply it with the differentiation of everything. And differentiation of something raised to power 3 means multiply by that 3, and then remove 1 from that 3. Because differentiation simply means multiply by the power, remove 1 from the power. Multiply by the power, remove 1 from the power. So whenever you have this, it is called function of a function. You differentiate the inside before you differentiate everything. So the shortcut said differentiate the bracket, differentiate everything. Differentiate the bracket, differentiate everything. So if I differentiate this bracket, I'm having 2. Differentiating everything means differentiating something that has raised to power 3, which means multiply by the power and remove 1 from the power. Very simple. So here will now give you 6 into 2s minus 5 all square. So the same thing we are going to do here. If we differentiate this bracket with respect to a naught, there is no a naught here. This is gone, 0. There is no a naught here, 0. There is a naught here, so it's going to be minus 1. Okay, so there is no a naught here, 0. And the differentiation of everything means multiply by, in fact, here I'm going to get, let me do it small. Differentiating the bracket, I'm having minus 1 here. Like I said, differentiating something that has raised power 2 will give you multiply by 2 into, you repeat it, I minus a naught minus a1 xi, all raised power 2 minus 1 will give you just 1. Okay, or you just ignore it, because differentiation simply means multiply by the power and remove 1 from the power. You understand? So which means, don't forget, is equal to 0, because we said that the partial derivative of it will give you 0. So now, so this means that what, our partial s over what, partial a naught will now be equal to what, sorry, I forgot the summation that is here. So it's supposed to be summation here. You know that we can bring the constant outside, so there should be summation here, please. Summation here, summation before all these people. So the answer will now be what, minus, this time this will give you minus 2 the summation of I starting from 0 to n of your yi minus a naught minus a1 x1 okay, is equal to 0. You understand? So if you divide both sides by 2, these two can come here, divided both by 2. So I'm having that 2 divided by this is gone, 0 divided by 2 is still 0. So I'm going to have that the summation of I starting from 0 to n of your yi minus a naught minus a1 xi. Please note the difference. This is not 1 but I. Okay, I. So is equal to 0. So, and you should know that our interest is to get our a1 and a naught. Don't forget, and we are still in the partial derivative of what a naught of s with respect to a naught. We have not done with respect to a1. So take note of that. So now don't forget that the summation of a plus b is the same thing as what? Summation a plus summation b. Please don't mind my own summation. So I can separate everything here to give me the summation of yi minus the summation of a naught minus a1 the summation of, okay, or let me just write it so that you not get confused. Let me put everything inside. Okay, so I'm having the summation of what? ai x I, okay, is equal to 0. So now we want to bring out our interest is our a naught and ay, so it can come outside here. So I'm having, this is the summation of yi. Don't forget that all these things, that I is starting from 0 to n. Please don't forget, your I is starting from 0 to n and your I is starting from 0 to n. So the main thing here are all these people with I. If you don't have I, you can easily come outside. Yeah, you should know that the summation of what? 2n, as n starting from 0 to infinity, can be that the 2 that does not have n can come outside. You will now have the summation of just n, as n starting from 0 to infinity. You understand? So anyone that does not have this I in it can come outside. So this a naught can come outside. I'm going to have a naught. Minus, it is minus here, minus a naught the summation of I starting from 0. Sorry. Okay, don't know what is wrong with this. Okay, starting from 0 to n of your what? 1 is remaining here because this came outside. So minus a1 the summation of I starting from 0 to n of your xi is equal to 0. So having known this, please, I don't want you to get confused. I'm just giving you some things that you need to remember. So having known this, you should know that that the summation of I starting from 0 to n of 1 is just repeating 1 plus 1 plus 1 up to n time. So it's the same as n. So the summation of a constant, the summation of any constant is simply that constant n. See, if it starts from 0 to n, you just attach n to it. You understand? So the summation of 1 is n. You understand? Because it's repeatedly up to n time. You understand? So I'm going to have that here will not be a naught n, because the summation of I starting from 0 to n of 1 is n. You understand? So I'm going to have that this is the summation of your yi, as I, don't forget that your I is starting from 0 to n, please, as I start from 0 to n of then here will now be minus a naught n. You understand? Minus a naught n, then minus your a1 the summation of your I starting from 0 to n of your xi is equal to 0. Now for us to get our a naught, if a naught move to this side, a naught n move to this side, so I'm going to have that the summation of I starting from 0 to n of your yi minus a1 the summation of I starting from 0 to n of your xi will now be equal to your what? A naught n. So if I divide both sides by n, I'm going to get my a naught. So here now I'm going to see that my a naught here, and I'm going to see that my a naught will now be equal to what? The summation. In fact, I can say 1 over n here into the summation of I starting from 0 to n of your yi minus a1 the summation of I starting from 0 to n of your xi. Okay. So let me call this equation maybe 2. I've gotten my a naught here, but the problem is that this my a naught is in terms of a1. You understand? It's not supposed to be in terms of a1. Yes, it's supposed to be just itself. But you can just note this. If you can easily get a1, then you come back and put it here and get your answer. So let us now do the partial. Let us now get this one. Let me scroll up so you see. So we have done this one. We have done this. So let us now do this one. We have done this one. We did this now to get that particular value. So now let us evaluate this one and see what we are going to get. Let us now evaluate this one and see what we are going to get. So to evaluate that, maybe you permit me to go to the next page. Let me go to the next page. So we still have that our s is equal to what? The summation of your I starting from 0 to n of your yi minus a naught minus what? a1 xi. Okay, then all squared. So we want to get partial s over partial a naught. Sorry, a1. Partial a1. So this is equal to, we are differentiating with respect to a1. So don't forget the method. Differentiate the bracket, okay, and use it and multiply the differentiation of everything. So if I differentiate this bracket, I'm going to have minus x, because in fact differentiation of 2x is just okay, let me say, sorry, differentiation of xy, and the differentiating with respect to x is just this y. So the differentiation of a1 xi with respect to this a1 is xi. You understand? So this xi, I cannot bring this xi outside this summation because it has I on it. So it's going to be, then don't forget that you are going to use it and multiply the differentiation of everything. And the differentiation of everything is simply to use this 2 multiply by the power and remove 1 from the power. So the minus will come outside. This minus, because of this, there was minus here, so there will be minus here. So the minus will come outside. The 2 that is a constant will come outside with it. I'm going to have the summation of I starting from 0 to n of xi. Remember, that is this xi here. I'm not bringing it outside because of this I. It will not come outside. It's not a constant. It will not come outside. So in bracket of repeating everything, then remove 1 from the power. So I have yi minus a naught minus a1 xi. Okay, then if you remove 1 from the power, so it's equal to 0. Don't forget. So if we divide both sides by minus, you see that this minus 2 is gone. So I am left with the summation of xi as I start from 0 to n of your what am I have of your yi minus a naught minus a1 xi, okay, is equal to 0. So we can open the bracket. Obviously, if we open the bracket, we are going to have the summation of I starting from 0 to n of your xiyi minus a naught xi, okay, minus a1 xi squared is equal to 0. So like I told you before that you can use summation to open the bracket. So let's use this summation to open the bracket. Remember that this should be like this. So let's share the summation to everybody. So I'm having the summation of I starting from 0 to n of your xiyi minus the a naught can come outside. So I have a naught, the summation of your I starting from 0 to n of your xi, okay. Then I'm going to have minus a1 will come outside too. I have the summation of I starting from 0 to n of your x squared is equal to 0. Now don't forget that we have gotten what our ai is before, our a naught. Don't forget we got that our a naught is in terms of a1, so we can just put it there. So our a naught then gave us at the previous page, let's check the previous page, our a naught, sorry, we got our a naught as 1 over n. Let me write that so that I can, we got our a naught to be 1 over n into summation I starting from 0 to n of your yi minus a1 summation xi. Okay, so let us put it there. So next page. So let us now, so we know that our x naught is something as 1 over n, the summation in bracket like this, the summation of yi minus a1, the summation of xi. Okay, so now if we fit it here, if we put it here, we are going to be having, so anywhere we see a naught we replace, so we are going to have that here is now the summation of I starting from 0 to n of your xi yi, okay, minus this is our a naught. So instead of putting this a naught, we are putting everything here. So let's open the bracket. It's going to be minus 1 over n, the summation of xi as I start from 0 to n, the summation of yi, okay, as I start from 0 to n. That is combining this one and this one. Somebody will say, why don't I do this times this to give you the summation of to give you summation x I y I? No, it's not the same thing. So just leave it that way, the way it is, please. It's not the same thing. Take note of that. You cannot multiply these two people to give you the x, the si and yi to come together. No. So I've just done this times this one. Okay, so next I'm going to do is this times this one, because I'm using a naught. I'm replacing a naught here to here, so everything here we multiply everything here. So if you use this and multiply this, they all come together like this. So if you use this one now to multiply this one, don't forget the 1 over n. So I'm going to have minus, okay, sorry, there is a minus here, so this minus will make this plus. So take note of that, the minus here, okay, no, sorry, the minus here is making this one minus, but the minus here will make this one plus. Okay, so let's take note of that. So let me clean this. Please don't, this minus here multiplying this will give you, there is minus here, so why this one will now be plus. So now we are using everything here to multiply this one and this one. So I'm putting my 1 over n to be here, then I'm having my a, I'm going to have my a1. This thing and this thing will now give you the summation of I starting from 0 to n of your xi. Somebody will say squared. No, it should be all squared. Okay, don't forget this is your a1, all squared. So this thing now and this one now should not multiply to give you x squared. No, it's the whole summation multiplying the whole summation. So it's going to be like this. So bring back your minus a1, this one minus a1, the summation of x squared to be equal to 0. So remember, we are interested in making a1 subject of the formula, so we can factorize here. So I'm going to have that the summation of I starting from 0 to n of your xi yi, then minus 1 over n, the summation of I starting from 0 to n of your xi, the summation of I starting from 0 to n of your yi. Then if you factorize here, they have ai in common, so plus ai that they have, a1 that they have in common. So what will I have inside here should be 1 over n, the summation of I starting from 0 to n of your xi, all squared, then minus what is remaining here is just the summation of your x squared as n, as I start from 0 to n, like this, equal to 0. So now if these two people now move to the other side, because remember the main aim is to make ai subject of the formula. So I have a1 subject. A1 will now be this one that is negative. First of all, move to the other side. I'm going to have, in fact, before that, let us multiply everybody by n, because I don't like this over n that I'm having everywhere. So let us first of all multiply everybody by n. So if you multiply everybody by n, multiply this one by n, I'm going to have n, the summation of I starting from 0 to n of your xi yi. Multiply this one by n, this one is gone, so I'm left with minus the summation of I starting from 0 to n of your xi, the summation of yi again as I start from 0 to n. Then multiply inside there. Remember, my a1 is still here, so multiply inside here by n. This is gone. I am left with the summation of xi, all squared, then minus n the summation of x squared, like this, is equal to 0. So these two we move to the other side, then we divide by this side, then we have gotten our ai. So our a1 sorry, will now be equal to this one that is negative moving first will now become positive. The summation of I starting from 0 to n of xi summation yi. Please don't forget that all these things from 0 to n, I don't want to start repeating it. This one has moved. This one that is positive moving will become negative. So minus n the summation of xi yi. Okay, then everything over divided by the coefficient of your a1, so which is the summation of xi all squared minus n the summation of x squared. So this is now the value of your a1. So the value of your a0 will now be, to put back your a1 now, don't forget that we got that that our a0 is equal to what? 1 over n into the summation of I starting from 0 to n yi minus a1 the summation of xi. Don't forget I from 0 to n. Okay, so we are putting our ai back. This is our ai, we have gotten it. We will now come and put it here. So our answer finally will now be, this will now be equal to 1 over n into, how do I write this now? Okay, 1 over n into, I have the summation of yi minus, so instead of putting this, we'll now put all this thing there. So that means we are multiplying everything here with our summation of summation x. You understand? So just do that and get your answer. Just do that and get your answer. Okay, or let me just do it. So I'm going to have summation. I want to write this one first. Summation xi into everybody here. That is summation xi summation yi minus n summation xi yi, then all over summation xi all squared minus summation n summation x squared. You understand? So that is how it's going to look like. So that will now be your a0. You understand? That will now be your a0. So this will now be my a0. Is there anything to simplify? Is there any way to simplify? We can simplify anyways, but now the main aim is, in fact, the thing is that all this process I'm doing here is just for us to get the value of a0 and a1. You understand? But there is a cheaper way of doing it. In fact, I'm going to be using 3 methods. There is a cheaper way to do it. You understand? So now let us use the alternative method alternatively. Okay, let me go to the next page. So that page. So alternatively, in fact, the last method you will like the last method alternatively. Okay, alternatively. So don't forget that we are having what do we have? Okay, we have that want to fit in. What are the things we have? Okay, let's start from the residue. Now that our residue x is equal to, want to minimize this residue x is equal to the summation of I starting from 1 to n of your yi minus capital letter yi. Don't forget this. So where this one is always something, the only thing we need is this one, and this one capital letter yi is something as saying what? a0 plus what? a1 xi. That is because we are talking about first degree. We are going to talk about second degree. So if it's second degree, I'm going to have plus a2 x squared I. But this is just first degree. So now let us get our derivative. So partial s over partial a0. Remember, like we did before. Okay, sorry, we are supposed to put it back. So this will now be the summation of your yi minus a0 minus a1 xi. Okay, so if I differentiate this, I'm going to have, remember we got it to be minus 2 the summation of your yi minus a0 minus a1 xi, okay, to be equal to 0, where we multiply both sides, where we divide by minus 2 to have that the summation of your yi minus a0 minus a1 xi okay, is equal to 0. So from here I told that we can share the summation for them. We can share the summation for them to have the summation of yi. Please don't forget that this thing I start from 1 to n. No, please don't forget, I don't want to be repeating it. So minus a naught summation 1, don't forget I told you before, then minus a1 summation xi is equal to 0. So I told that summation 1 is same as n, so which means we have summation yi minus a, what am I saying, a n, then minus a1 the summation xi, okay, is equal to 0. So let's leave this y on one side, then the rest will go to the other side. So I'm having that this one going to the other side, I'm going to have a n, this one going to the other side, I'm going to have minus a1 the summation of xi is equal to what, the summation of yi. This should be your equation 1. Okay, then you will now do the same thing for the second the other one, which is what, partial s over what, partial a1. Remember that when we did it, we got I think minus 2 again, minus 2 the summation of xi into let's see, it's going to be si into yi minus a naught minus, okay, so let us fix it. You can differentiate it yourself. You know, the way I'm scrolling, I will not be seeing the other side. So I'm having si, then I have yi minus a naught minus a1 xi, okay, is equal to 0. Okay, from here divide both sides by minus 2. I'm having the summation of xi in brackets of yi minus a naught minus a1 xi is equal to 0. So if I multiply out by xi, I'm going to have the summation of xi yi, okay, then we go again minus a naught the summation of xi. I'm multiplying everybody here by the summation of xi. So this one times this is giving me this, everything here times ai will give me this one, everything here times this will give me minus a1 the summation of what, xi squared is equal to 0. So let the one that have y to be on the other side. So moving all this one that has minus first, I'm going to have your a naught summation xi minus a1 plus a1 summation x1 xi squared is equal to this one remaining here. I have summation xi yi, equation 2. So if you can get all these ones are easier. To get summation I will be easy. To get summation to get summation x squared will be easy. To get these ones are easy. To get this when I solve the example you understand, and all these are easier. So once you get them now and put them inside there, you will now see that you're having equation 1 and 2. You will now solve that equation 1 and 2 simultaneously, and then you can now get your a naught and a1 instead of using that long method. You get your a1 and a naught immediately, and then you are good to go. Okay, so that is for first degree. I'm going to do for second degree, and then give you a general way of getting all this formula. Then we are good to go. So we now solve an example, then we are good to go. So the next thing, go to the next page. Let's solve for degree 2. So for degree 2, you don't forget that we are going to look at that y will now be equal to what, a naught plus what, a1x plus what, a2x squared. If you look at this, see that for degree 1 we are looking for 2 unknowns. So for degree 2 we are looking for 3 unknowns, and the 3 unknowns are what, a naught, a1 and a2. So if I can find all these things, I come back and put it in this equation, then I'm done with what I am doing. Okay, so that is that. So now let us move. Remember that the method we are using is a least square method. Okay, least square approximation method. And for least square approximation method, we are using our residue. So our residue s is equal to, remind me the formula, don't forget please. When I say before I write it, the formula will not be what, the summation of what? Summation of I starting from what? 1 to n of what? Of your yi minus capital letter yi. It's easy, all squared. Very simple something. You understand? It doesn't change. So, and then your y, your capital letter yi will now be equal to what? A naught plus, you come back here, you are getting it from this your y here. You understand? But this one has I now, so all this your x will now have I. So now be a1xi plus what? a2x squared I. You understand? So carry this now and replace this. This is very easy. So you have your s will now be equal to what? The summation. Deriving this formula is easy, but instead of deriving the formula, I will show you the last alternative, which is a very simple way of getting the formula without deriving it, without doing all this derivation. So I'm going to have I starting from 1 to n of your what? yi minus, you now put everything here. So minus times the first one, you have what? A naught. Minus times I have minus a1x1i. Please don't plus, sorry, minus, not plus. Okay, so minus what am I saying? Minus a2x squared I. Okay, then the next thing you are going to do is to get the first derivative of each of them. Okay, so the partial derivative of each of them. So I'm going to have partial s over partial a naught is equal to, don't forget the method. The method is to differentiate, sorry, there is squared here. So the method is to differentiate the bracket, which will give you minus, then the 2 will come to the other side to have minus 2 the summation of I starting from 1 to n of your yi minus a naught minus a1xi minus a2x squared I. Okay, is equal to what? 0. So if you divide both sides by minus 2, I'm going to have that what? That the summation of I starting from 1 to n of your yi minus a naught minus a1xi minus a2x squared I, okay, is equal to 0. So share the summation for them. If you share the summation for them, I'm going to have the summation of I yi. Don't forget it is from 1 to infinity. I don't want to be writing it. So minus a naught summation of 1, then minus a1 summation of xi minus a2 summation of xi squared, okay, is equal to 0. So remember, we are taking the one that has y to the other side. So okay, let's move all this one that does not have I to the other side. So I'm going to have my what? Going to have and I told that summation 1 is n. So here is going to be a naught n, okay, a naught n. This one moving here, the other one coming. I'm going to have plus a1 summation xi plus a2 summation x squared I is equal to this one, the other side, to be what? Summation yi. Don't forget that the summation start from 1 to n. So now this is our equation 1. We have gotten our equation 1. So let us do for the other one to get our equation 2 and our equation 3. So I repeat my s so that I will know what I'm doing. My s is equal to what again? So my s is equal to, that is the summation of yi minus, I think I have a naught minus a1x I minus a2x squared I. Okay, we have this as our s. So we are now dealing with partial s over what? Partial a1. That's the next one now. So which is what? If we differentiate here, we are going to have minus xi, and that si should be inside the summation because it has I. So the minus is coming outside here. So the 2, sorry, the squared here, the 2 here will come to multiply. I'm going to have minus 2 here. So I have the summation of, so the xi will now be here, into, repeat everybody here, yi minus a naught minus a1xi, then minus a2xi squared. You understand? Don't forget it's equal to 0. So divide both sides by, this is summation. divide both sides by -2 so that -2 will go outside. So divide -2 divided by -2 gone. 0 divided by -2 is 0. So I'm left with what? The summation of what? Open this bracket, I have SIYI minus what? A0XI minus what? A1XI squared, then minus A2XI cube is equal to 0. So share the summation for them. I'm going to have that this is now the summation of XIYI. Don't forget there should be a bracket here. So minus A0 the summation of XI minus A1 the summation of XI squared minus what? A2 the summation of XI cube is equal to 3. So everybody that does not have Y should move to the other side. So I'm going to have the first person here moving. I'm going to have A0 the summation of XI plus A1 the summation of XI squared plus A2 the summation of summation of X, not A. Okay, so the summation of XI cube is equal to this one now that has Y in it, which is what? The summation of XIYI, equation 2. So to get our equation 3 is to do the derivative of S with respect to A1. So our S again is equal to what? Your summation. So our residue S is equal to what? The summation of your yi minus A0 minus what? A1xi minus what? A2x squared I. Okay, so we take the derivative. So partial S over partial A2 now. Okay, will now be equal to, be careful, if you differentiate A2, we are differentiating A2, is going to give us minus x squared I. So the minus will be outside, and sorry, the squared here. The 2 here will come and multiply to have minus 2 here, the summation of, so what I'm supposed to have inside here is x squared I, because the differentiation of this is giving minus s squared I. So the minus is outside here, the s squared I is inside here. So the 2 here is multiplied by the power, remove 1 from the power. That is the 2 I'm having here. So to remove 1 from the power, I'm going to have yi minus A0 minus A1xi minus A2x squared I, okay, is equal to 0. So if you divide both sides by -2, this -2 is gone. So I am left with the summation of your x squared I. Okay, let me open the bracket. S squared I times it to give you yi minus A0 x squared I minus A1x cube I minus A2x 4I, okay, is equal to 0. So share the summation for them. If you share the summation for them, we are going to be having, I think these are okay, thank God. I'm going to be having the summation of x squared I yi, okay, minus A0 summation x squared I minus A1 summation x cube I, then minus A2 summation x4I is equal to 0. Okay, so now the one that has y should be on one side. If you don't have y, go to the other side. So I'm going to have A0 summation x squared I plus A1 summation x squared s cube I. So minus plus A2 summation x4I is equal to what? The one that has y, which is what? Summation x squared I yi. Okay, so this is our equation 3. So now, so I told that it is easy to get all these ones with summation. If you can get all these ones with summation, you now have 3 equations. Then you now solve simultaneously 3 unknown and 3 equations. You understand? So now, instead of using this method of derivation to get this, another alternative method of getting all this, your equation 1, 2, 3, is by using your matrix. your matrix. Okay, some call it matrix, some call it matrix, I don't know, depends on the one you call it. Matrix. Okay, let's use another alternative. We have not solved an example alternative, so we're going to use the matrix method. And remember, for matrix, for a linear equation, for a system of linear equation, we have that what we always have that ax is equal to b. For a matrix system of linear equation, if you want to solve a system of linear equation using matrix, you have ax is equal to b, where your a here is the coefficient of the variable, obviously. Okay, where a here is the coefficient of the variable, and then your a is equal to coefficient of the variable, and then your x is the variable itself, then your b is the constant, the right hand side, the constant, or the right hand side constant. Okay, now if you remember those our equation 1, equation 2, equation 3, you will notice that our a, which is the coefficient of those, our a0, a1 and a2, like that are all the variables, while those summation something is the coefficient, and then the right hand side is the other one, if you can remember. So let us do that. So I'm going to have that this is going to be, I'm going to write my a now. My a are all the summations. So I have the first one is summation x0. That's how to write it. The next one will now be what? Summation x1 xi. The next one is what? Summation x squared. Remember that all these things are I. Okay, then the next one will now be what? Summation what? This is my summation. It's not easy to, it's not difficult to write. So start from what? x0, x raised power 1, x raised power 2. Then next one will be what? Summation x raised power 3. Don't forget that it is I, and it continues like that. Okay, it continues like that. So the same thing here again. The same thing you wrote here is same thing you're writing here. So we have written the 0. So the next one we're writing is what? Summation x1 I. The next one will not be what? Summation x squared I. The next one will not be what? Summation x3 I, and it continues like that. The same way this one continues. Now to fill into this place is just it will not be just multiplying the x and x to give you x squared. So I'm having summation x squared I. Here will not be what? Summation 1 and 2 to give you 3 x cubed I. And it continues like that. Just want to, so for this side will not be what? This time this will give you summation x3i. This time this to give you not everything. No, I'm just using the x to times the x, not the summation times in the summation. Please note that too. So we'll give you x 4i, and it continues like that. So this one will not give you summation 2 and 2 to give you 4. So it continues like that, it continues like that. So that's the way they continue. Okay, so you have known how to write that. So then our x is the variable, and our variable here are all what? x0, x1, x2, x sorry, not x, a1, a2. What am I saying? Sorry, a0, a1, a2, and the rest of them, a2, a3, and it continues like that. Okay, so it's equal to, now the right hand side becomes your y, those that has y, which is what you will start from the summation yi. Please remember that in your equation that the yi remain constant, that what is changing is the x. There is xi raised power 0 here, but x raised power 0 is 1. You understand? So here I'm going to have, here will not be, okay, there, let me just put it for just teaching sake, raised power 0. So it's only this one that will be changing. So the next one on the second line will now be what? The summation x1. There is one here, yi. The yi remains the same. So the next line, the third line, should be what? Summation x squared I yi. It remains the same. So the next line should be what? Summation s cube yi, like that. You see how this one looks like? So that is how. Now don't forget that anything raised to power 0 is 1, and summation 1 is n. So that is the work of, so here I can change it to be n. So everything here is something as n. I told you before now. So don't forget that. So let me, instead of putting the, let me change it to n now, so it will be easier. So everything here is n. So I remember in the multiplication of matrix, the role we multiply the column. Don't forget, roll multiplied by column. So if I want to get for second degree, for example, okay, let me get for first degree, then get for second degree. Let me do all of them. So the first one is for first degree. Let's get the equation for first degree. So for first degree, or degree 1, let's call it degree 1. Degree 1. So for degree 1, I'm going to be you will know that degree 1 is two unknowns. Don't forget A0 and A1. So I'm going to be using 2 by 2 matrix. So for degree 1, it will be ending somewhere here, 2 by 2 matrix. So I'm going to have our n, then this side should be summation summation xi, and then here will now be what? Summation xi again, and then here will now be summation x squared I. Then I'm going to have A0 and A1. Then this side I'm going to have the summation yi, and then the summation x I y I. Okay, so now if I now solve this, if I now multiply the normal method of matrix, this will multiply. So I'm going to have A0 n plus this one multiply this one. So I have A1, this one multiply this one, this one multiply this one. So it's going like 7, like this. This side multiply this side. This one now, let me use different. This one we multiply this one, while this one, the row is multiplying the column, we now multiply this one. So that's how it goes. N times A0 to give you this one. So this one times this will give you. So I'm going to have the summation what? Xi. Okay, we now be equal to what I'm having here, summation yi. That is our equation 1 for first degree. Let me look for it. Equation 1 for first degree. See our equation 1 for first degree. See, it's the same thing. So look at this. An minus A1 summation x1. Let's check if it's the same. Is equal to summation yi. Let's check. Go this. You see, A0 n plus A1 summation xi is equal to this. See, correct. So the next one is this row multiplying the column again. So that means this one now, this one we still multiply this one, while this one we still multiply this one. So we'll go again. So we're going to have this time this to give you A0. Okay. So for this one to multiply, so I'm going to have what? A0 summation xi, okay, plus this one multiplies one to have what? A1 summation x squared I, okay, is equal to what? Summation xi yi. See that? So that is our equation 2. So let's check if it's the same thing. Go to the previous page, equation 2. So the mistake I made here was what? A0 n, please. It's A0 here. Don't forget, this is A0. Summation 1 is n, so there is not in it, please. So our equation 1, A0 this, see, they are the same thing. Let's check again. This one has square, this one is x and y. So let's check again. Next page. I said this one has square, this one has x, and so that is that. So let's write for degree 2. So for degree 2, you permit me to clean here so that I can be seeing what I'm writing. You permit me to clean degree 1. So let me just use big eraser and clean degree 1 and write for degree 2. I think the video is becoming longer, but sorry about that. Okay, so for degree 2, for degree 2, now degree 2 will give you 3 unknowns, so we are using 3 by 3 matrix. So I'm having n here, I'm having summation xi, summation x squared I, 3 here. So we are going to complete the 3 here. So the 3 here will now be what? Summation xi. Here will now be what? Summation. Here and this summation. Okay, we're having summation x squared I. So here will now be summation x squared I. Here will not be summation x cube I. Here will not be summation s cube I, and then finally summation x4I. So 3 by 3. So this side is 3, and then the unknown are what? A0, A1, and A2. These are the unknowns. And then the right hand side will now be what? Summation yi, summation xi yi, and finally summation s squared I yi. Okay. So the same method again. Row multiplying column. Don't forget, in matrix, that's how it is done. So which means this one will multiply the first one, while this one will multiply this one, and then finally this one will multiply this one. It will now be equal to this one, the first line. So we go again. We'll go again on the same line. So that is it. So let's go. So n times this will give you what? A naught n plus, this time this will give you what? A1 summation x1 xi, sorry, plus A2 summation s squared I will now be equal to summation yi, equation 1. So let's verify if the equation is correct. Equation 1 of, sorry, should be next page. Equation 1 here. See it, equation 1, see, very very correct. So go to equation 2. So equation 2, so I do the equation 2 for me, so that I will know that you are getting it. Do it first, then let me give you 3 seconds. If you write it, then I will not write my own. You now check if you got it. Let me write my own. This will multiply the first one to have what? A naught summation xi. This one multiply this one to have what? A1 summation x squared I. Then finally the third one to multiply this to have what? A2 summation s cube I is equal to the right hand side, summation xi yi. Okay, so finally write equation 3. Let me give you 5 seconds to write equation 3, then I will now write my own. You will now know if it's correct. 1 2 3 4 5. Time up. So I have what? A naught again. The first person is multiplying the first person, so A naught, the summation s squared I, okay, plus A1, the summation s cube I, plus A2, the summation x4I is equal to the summation x squared I yi. Okay, so equation 2, equation 3. So now, even without matrix, you look at this, you see that it has a pattern. Even without matrix, you see that it has a pattern. That the first one, equation 1, should be A naught n plus, it will now continue to A1 summation x1. The next one will now be squared in this summation, so A2 summation x squared. You will now have summation y1. So the next one now is to multiply everybody here now by summation x1. You understand? You get the next equation. So the next equation, then throw away this n. The next equation will now look like A summation xi. That's what we are multiplying with, plus this one will now turn to squared. So A1 summation xi. This thing is I. So here will now be squared. This one will now turn to cube. So now be what? A2 summation s cube. This one will now turn to what? Xi yi. So multiply this, the next one. This one should be your equation 1. So multiply equation 2 by the same xi again. So it will now be what? A naught summation x squared I plus what? A1 summation x cube I plus what? A2 summation x4I is equal to what? Summation xi squared yi. You see that? So getting these 3 equations are very very simple. Even if you don't know how to use the matrix method or this method, so you can just use the pattern to get that. So we can now solve an example to illustrate everything we have been doing so far. So let's just solve one simple example, then we are good to go. Next page. So on this example, where is that my example? Okay, so example say using using the or use the least square method, okay, to fit the line, to fit the lines, or sorry, to fit the line, not lines but line, okay, to fit the line a plus bx, okay, for the first point they gave you is 2 comma 1, the next point they gave me is 1 over 6 comma 5 over 6. They can give you any point. The next point they gave me is minus 3 over 2 comma minus 2, and then the last point they gave me is minus 1 over 3 comma minus 2 over 3. Okay, so now to solve this, what we have to do is the first thing, I like solution. The first thing is to draw you can write your equation. It depends on what you want to use. Now let us use the second order, because the higher the order, the more accurate your result is. Okay, the higher the order, the more accurate your result is. Or let's use first order. Okay, no, sorry, we're going to use first order because this is first order linear equation. Please, we're going to use first order here. Okay, so what do we need to get? We need to get our a and b. So that is, if you remember that your y is equal to what? A0 plus a1x is written as what? A plus bx. So sorry, a1. So that means they replace a0 with a and then replace a1 with b. So they use a0 as a and then they use your a1 as b. So it's the same thing, nothing has changed. So if you remember that the method of solving this is let us get our equation. Very important. So to get our equation, remember, is 2 by 2 matrix. So if you know the first equation, then the other one will now be very simple for you. So for 2 by 2 matrix, you are going to have a0 summation x naught I, which will give you n. Okay, just n. So just know the pattern. Just know the pattern. If you know the pattern, you are good to go. Even if you don't want to start doing matrix and the rest of that. So just know the pattern. A0 n. Then the next one will now be what? A1 summation xi is equal to what? You now have summation yi. So the next is to multiply every bird by summation by xi. But don't forget that si will not have summation. So this one will not change to what? A0. Instead of this, it will not be summation xi. You understand? Plus here will now be what? A1 summation x squared I will now be equal to, here will now be what? Summation xi yi. Okay, I think that is how the two equations will look like. So now, having these two equations, the next thing you are going to do is to draw your table. I like drawing my table. So when you draw your table, you know what you are doing. So let us draw our table. So to draw our table, we are going to have in the table now. In the table, we are going to have our xi. Okay, so let's draw our table. So we need, if you look at all these things, you see that what we need our xi. We need our what? Yi. So the next thing we need is our s squared. We need our x squared I. So the next thing we need is our what? Our x and y. Xi and yi. Okay. So now from the points they gave you, the first point is, all these points are our x. Let's call it x1, y1, x2, y2, like that. So you will start from 2 and 1. You understand? So it's easy. So right, the first point is 2 and 1. So the next point is 1 over 6 and 5 over 6. The next point is minus 3 over 2 and minus 2. So the next point is minus 1 over 3 and minus 2 over 3. Okay, so now we need their summation. So the next thing to do is that we need their summation. So if I sum all these things, sorry about the one. So if you sum all the x to get your summation x, you have that here is your 1/3. Sum all this one to get your summation 1, you have minus 5/6. Then x squared means to square this, so this squared will give you 4, this squared will give you 1/36, this square will give you 9/4, this square will give you 1/9. Then if you add all these things here, you're going to get 115/16. So x and y is to multiply x and y. 2 times 1 is 2, like that. So if you multiply, you're having 5/36 multiply x and y to have 3, to have, is it 3? You have 3, yes. So to multiply the last one, you have what? 2/9. And if you add all this, you are getting 193/36. Okay, so then the next thing you are going to do now is now to start putting it. So I have your an. Remember that your n is 4. Why? Because I'm having 1 2 3 4, so my n is 4. So you can say n is what? 1 2 3 4. So my n is 4. So I'm going to have from the first equation here, I'm going to have an, that is what? 4a0, that is 4 times a0, 4a0 plus summation xi is 1/3. So I'm going to have 1/3a1 is equal to what? Summation y gave us minus 5/6. Okay, so if I multiply everybody by 6 is the common ratio. If multiply by 6 times this will give you 24a0 plus 6 times this will give you 2a1 is equal to minus 5. So this is your equation 1. You understand? So we'll do the same thing here again. So a0 summation x1, which is 1/3a0 plus, okay, this is minus, so there should be minus here because summation of y, what am I saying? Summation s squared, summation s squared gave me this, so it's going to be what? 115/16 a1 is equal to what? S and y, summation s and y, which is giving me 193/36. You see, so you can, I think 36 can go for everywhere, right? Check the LCM and multiply by the LCM to get your equation 2. If you now solve that equation 2 simultaneously, you will now get your a1 and a2, and your a0 and a1, and your a0 is same thing as your a, which if you solve it simultaneously, you will get minus 782/2913. Okay, and then your a1 is your b. So your a1 is the b they gave me, which after solving you are going to get 782/1031. So your final answer becomes, remember that the equation they gave you is that y is equal to what? The equation they gave us was what? Y is equal to a plus bx. That's what they gave us. So y will now be equal to, now put your a, minus 782/2913 plus 782/1031x. Okay, so that is that. So now remember that this thing is a linear equation and is a function. So this thing means that the meaning of this is that f of x, y is equal to f of x. This y is equal to a function of x. It means that if you carry any value of y they gave you, like that place they say that that the first coordinate of 2 and 1, it means that this is your x and your y. It means that if you put your x here, if you put 2 here, you are supposed to get 1 as the answer. You can try it. Now you will not get exactly 1 because this is the approximation method. You get something that is very close to 1, but you will not get exactly 1. That is why it is called the what? The least square approximation method. So if you approximate your answer, you will not get the correct thing. You understand? So you get something that is very close, an approximated value. You understand? So you will not get exact, you get approximated value. But the higher the degree, the more accurate your answer will be. If you do degree 5, it will be getting close to 1. Degree 10, it will be, you understand, until it. So the higher the degree, the higher the accuracy of your results. So thank you very much for watching. The video has already taken so much time. Please don't forget to like our video, subscribe, and drop your comments. May the peace of the Lord be with you. Bye bye.